Welcome to the Data Architecture Elevator podcast. Created by Agile Lab, we will explore the dynamic intersection of technology, innovation, and practices in the data space. Our company purpose is to elevate the data management game of companies that want to be data-driven, and this is the goal of this podcast too. For more information and insights, visit our website at www.agilelab.it and feel free to reach out our architects on LinkedIn with your question. Now let's step into the elevator with Agile Lab Data Architects. Hello and welcome to the third episode of Data Architecture Elevator series. This episode will focus on the evolution of analytics. So we will talk about accelerated analytics. In today's fast-paced digital world, data is everywhere, from customer behavior and market trends to operational efficiency and supply chain management. The insights that data can provide are invaluable. But as data volume grows, so does the complexity of analyzing it in a timely manner is increasing as well. So that's why we need to talk today about accelerated analytics. And today with me, we have Francesco Valentini, Ugo Ciraci, and Antonio Murcia.
Hi, everybody.
Hi.
Okay, so what exactly is accelerated analytics? Basically, is the process of speeding up the data analysis to deliver insights faster than traditional methods. By using advanced computing technologies like in-memory computing, GPU acceleration, or even machine learning, is it possible to reduce the time to insight, even on complex and large analysis? But beyond the speed and accelerated analytics could also enhance the depth and the breadth of data analysis. And we will see which possibility we have. During the last decade, I think we moved in several evolution of data processing. So we moved from in database processing, then we moved into massive parallel processing, still inside the database. Then we had the decoupling between storage and computing, always leveraging distributed computing, then GPU acceleration, and now the last trend seems to be in-process analytics. So we will see if we are coming back into single instance processing or not. So maybe, Ugo, what do you see in the market? Are companies looking for faster analytics, cheaper analytics, or focusing on analyzing always increasing amounts of data? What is the goal that you see?
Well, actually, I would say that competition is heavy out there, and companies free to make decisions very fast. Making decision requires to turn data into values, and to turn data into values very frequently, and this means having analytics supporting those decisions. I mean, I would say that the driver is making decision fast. And then when you accumulate multiple, technical stack technologies to do this effectively, then you start looking into the cost efficiency. And then you start also looking how to make this cheaper and to scale in terms of sustainability. That's more or less what I see. And and this is also a major trend if you see how cloud provider they GPU accelerated services, managed services with such a capabilities, and they are starting serving multiple more and more use cases, more in the from ingestion to serving layer, that actually impact all the value chain until you take a decision, that you start doing the real analytics for final users. This is more or less the trend that I see, but I would say the driver is being fast.
And Francesco, what is your view in the market?
Okay, Paolo, I think I basically agree with Ugo, but I think that both sides of the medals should be kept in consideration, since I think both are important drivers for faster analytics and cheaper analytics. So the key distinction between traditional analytics and accelerated analytics relies in speed, efficiency, and scalability at which data is processed and the insights are generated. So advances in data processing technologies, infrastructure, and analytical methods have enabled organizations to transition from slower conventional approach to optimizing and faster system. So this improvement can stem from, in my opinion, both from hardware and software acceleration techniques. So on the hardware side, you have, as has been mentioned by Hugo, GPU acceleration. Okay, so with CPU accelerated database that is going to allow organization to stream, process, and query very large data sets in seconds or milliseconds rather than hours or minutes. So both deployed on premises or in the cloud. And this is also going to have a side effect on cost and cloud spending over, for example, the cloud. So this is what I think this is going to drive and also bring benefits on both sides. Faster analytics and also cost optimization, and then cheaper analytics, in my opinion.
Nice. Yeah, and talking about the last new wave in this world. So after decades of distributed processing, it seems that in order to place analytics everywhere, we are moving back to single instance process. Antonio, what is your idea? Is it sustainable also to go in the direction that Ugo and Francesco highlighted? So being faster and cheaper and more, let's say, everywhere, ubiquitous.
So I think this is a nice trend in the end. It's going to be very useful. I also think it's not feasible for every company to just go back to single instance analytics because at some point you hit a wall. Horizontal scalability has proven to indefinitely scale more or less, while obviously vertical cannot match that kind of scalability. But many companies out there are okay with a single instance database to do their analytics. So moving into the compute and storage separation for them is a huge benefit because they can swap mainly compute with the tool they find best for each purpose. So I think is a very good trend, and it enables one more thing, which is actually possible to postpone some processing to the very last step of the data chain. So it can be even in your browser or in the data-facing application that you can use these new engines, single instance engines, and let's say remove some of the load from the bigger and more complicated distributed engines that are usually employed in prior steps. So I think in the end, it gives us more opportunities and more choices, which is always a good thing.
Did you see, maybe this question is for everybody, did you see any of our customer looking into this pattern and to solve which particular problem? It's a matter of agility, fast prototyping, or real production. Did you see any of our customer go in this direction right now?
Right now, I only see that the day-to-day job of data scientists is much more simpler because they are better integrated, let's say, and they can still run their analysis, but using simpler tools. Because every time you move back from distributed to local engines, the API gets a bit easier to debug, etc. So this is what I see. I didn't see any of our customer catching the opportunity to move some computation, let's say, closer to the end user. Just once, I guess, actually happened when we used DuckDB inside a Java application, a microservice, to serve interactive queries from behind a REST API, and that worked quite well because the dataset wasn't that huge. So yeah, just once, let's say, but I see in the future that's gonna happen more and more.
Okay. If I can give you my perspective on this, Paolo, I think most of the customers are embracing this approach, mostly for generative AI stuff and machine learning. For the big data and TL side, they are mostly going with distributed computing. I think they are still far away of adopting this new kind of technologies. I believe, and also I hope, that in the future we are going to move forward an hybrid paradigm where a unified application interface will manage execution across both type of engines. Okay, single node massive parallel GPU powered or process parallel like Polars, and distributed workloads for scenarios where data exceeds the memory capacity of a single machine. Another potential approach, in my opinion, is an effective combination of these two methods. So maybe notable examples are that kind of library that give the possibility of accelerating Spark job by leveraging the powerful of internal library of the hardware, and also without losing the possibility of compromising the distributed nature of a Spark engine. So in terms of scalability, this is what I think on this topic.
So you envision some kind of routing layer that can balance dynamically or configurable between efficiency and scalability based on the scenario that the query need to go through. That's probably something really feasible also.
Yes, that's right.
Good. The foundation of this new wave of analytics, we have seen that is largely based on Arrow and also in some case Rust as a language. Can you explain, Antonio, how these two elements fit in the picture?
Sure.
Is it something that we need to deal as an end user or not?
So first of all, I don't think is something we will have to deal as end users so much. we must acknowledge that they exist, especially for Arrow, but the impact on our day-to-day job is not going to change that much. We learned what are the advantages of a columnar storage format with Parquet. I guess everyone in the community now understands why Parquet is good. And Arrow, just to give an introduction, is mostly the same, but for in-memory data. So what Arrow is a memory specification, let's say how to lay out data in memory for, let's say, table-oriented data structures. And the advantages more or less are the same as Parquet, so it's interchangeable. This means that different tools can read the data not only from Parquet file on disk or on object storage, but also they can share this data structure inside the same machine without ever going to disk, let's say. So the implications are the same. Like remember, you're using a columnar format, so you would get a huge improvement if you project on some columns, but not much more than that. And for Rust, I think its usage is gonna be relegated to the engine. So if you're developing a new engine, yeah, you probably need to deal with the Rust. Otherwise, there are going to be bindings that allow to call the engine from a higher level API that can be in a different language, like Python. Python libraries do this all the time since ever, and I think in the future also other languages are going to go with this approach, so that you don't need to deal with low-level code to actually perform analytics. And for sure,
Rust is improving the performance during the query execution. So what is the difference with query engines implemented in Java or...
Definitely what you're getting with Rust versus Java implementation is you don't have a garbage collector around, so query times are more predictable. Like that's the problem with the JVM is that at any point garbage collection can start, and that will eat your latency. This cannot happen in Rust. Also, Rust as a language is designed to be as efficient as possible. So this can give an improvement too. Even if I don't personally think this is my personal thought that memory layout is much more important than efficiency in a single operation, because Java or the JVM is quite fast at adding or multiplying numbers even by itself. I don't think you get a real speed up in doing that using a language like Rust. What you get is lower latency for sure, lower startup times, and definitely more predictable latency. But in the raw throughput for queries that run for minutes or hours, which might be ETL job or things like that, I don't think Rust is moving the statistics so up. It's more about the memory layout probably, and the way you Yeah,
Arrow is more important than Rust in this. Yeah, I think so, because I have seen in the past many query engine also using unsafe memory in Java. Maybe that could be a bypass of garbage collection and so on. Maybe it's more complex to develop in a unsafe mode, but could be a solution. I was wondering, because I don't know Rust, if it's introducing some operation pipelining or vectorization of multiple step transformation by design in the language or not, or it's something that you need to build always by yourself in the query engine.
No, that's something that that Rust is doing automatically, but that happens in the JVM too. Actually, it's something more low level, so you don't need to build specifically for that. Definitely, it's a more modern language, so probably has more opportunity to do that than a JVM language. But I think, yeah, again, it's the memory layout and Arrow that matter the most in this kind of situation. Also, it's the blending of the queries that matters more than the speed you can actually perform the computation. Because there isn't much to squeeze in that direction with general purpose hardware.
Yeah. And in terms of tools and products going into this direction, which are the most promising that you see in the community?
So definitely DuckDB and Polars are kind of the new kids on the block. There is also Apache Data Fusion, which is not a product, but is a analytics engine. Again, single node, built on top of Arrow and written in Rust language, so that can be used as a building block for building new engines. One of them is Comet, which is a replace of Apache Spark engine, so you can run Apache Spark application and plug in Comet engine that will speed up some queries, not all of them. Going back to DuckDB, for example, I see the choice that the development team has made to building that in WebAssembly technologies is that you can run it anywhere, definitely everywhere.
Also in the front end, maybe.
Yeah, you can build it in the. You can run it in the browser too, and that's so. DuckDB had kind of a spin-off company which is called MotherDuck, and MotherDuck is a SaaS, SaaS, which actually gives you a platform built on DuckDB, managed. And what they do is perform some analytics in the backend using DuckDB, and then what makes sense to do in the front end, they do it in the front end in your browser. So I think that improves latency for sure, because you already fetched the data locally, and then you can analyze it locally in the browser, and also gives them a huge advantage because they don't need to juggle between two different technologies. It's always DuckDB on both sides. So I think that's very interesting. On the other hand, Polars sits on a decade or more of Pandas adoption. So Polars is just a replacement for Pandas with the same APIs, but written in a more performant language, which is Rust, using Arrow under the hood optimize analytics. And so this is, let's say, drop-in replacement. If you were using pandas yesterday, start using polars today, and you will get only benefits.
Clear. And instead, what about GPU acceleration? Is something that is applicable to analytics? Because I remember in the past, at certain point, there was a huge traction of GPU databases with a couple of vendors working on it. Also tried some of them with incredible performances on some pattern. Is something coming back with this huge traction of NVIDIA? Did you see something about that?
Yes, Paolo, I think, in my opinion, on the GPU acceleration side, the market is dominated by NVIDIA processor. And their proposition in the past, as you correctly mentioned, it was about accelerated databases that are going to allow organizations to stream, process, and query, analyze data sets very, very quickly. And basically, there are several databases that try to basically go in this direction, like, for example, Kinetica or Single Store, that they are CPU accelerated, distributed, and they are very good for enabling real-time intelligence. Or otherwise, for example, Single Store is also cloud native and give also the possibility to do SQL, and is a very modern database, including structured data. It is able to handle semi-structured data and so on. All this kind of layer of abstraction has been made possible by introducing and dealing with, let's say, CUDA libraries in order to leverage the GPU capabilities. But currently, something more easy to do is coming up in the market. Also, maybe proposing something that is going to be interoperable with Spark, for example. One of the enhancements that engineers at NVIDIA provided is Spark Rapids, that give the possibility to plug in within the Spark applications several JAS that give you the possibility to leverage GPU acceleration within the classic ETL jobs of a Spark application. It's very easy. You don't have to change your code, and you will gather only the benefits of combining distributed processing and also GPU acceleration on the single node, when maybe, let's say, the nested, the physical plan of wide transformation happens within the single machine.
And this is completely transparent in terms of API.
Yes, this is the major benefits, in my opinion. It is transparent and gave the possibility to reuse all the things that you have done in the past with your SQL code. Just add the archive, the jar within the class path, and also you have to use GPU accelerated machine for your workload, okay? And this is going to give you some acceleration. They claims that they can also speed up computation and minimize costs up to 70%. This is another item that...
because this is super interesting, in my opinion, for a company that has a large code base in Spark, large transformation and whatever. So if it would be possible to replace the engine of Spark with something else, and maybe, I don't know if there are other Spark accelerator, maybe even not using GPU, that would be a huge benefit, because basically with zero effort, you can save a lot of money in cloud spending. You can also reduce your timeline of your data pipelines. So, Antonio, is there also some other Spark core replacement that is providing acceleration in this area?
So as I was saying earlier, there is Apache Comet, which is now an Apache project, or is graduating as an Apache project, which is was born into Apple. So Apple developed it internally and then donated it to the Apache Foundation, and it's a Spark compatible engine built using Data Fusion, which again is built on Arrow and Rust. So the lower level of the tech stack is changing, but not the higher one. So you still take your Spark applications, enable Comet, and you are good to go. Obviously, it's not a very mature technology, and there is no major, let's say, Spark provider which supports it out of the box. So you are a bit on your own to try that out. We are doing some research on this. We've done some research on this. And for example, it's quite hard to use it on AWS EMR. For example, it's easier to use it on Cloudera instead. And
because you can mod the Spark jars and distribution. So in some environment you cannot change the jar of Spark, right?
Well, that's a reason, but the real reason, let's say, is that Apache Spark distribution on EMR is different from the open source one. In some signatures, in some things, Amazon wanted to push some changes which are incompatible with the open source implementation. Which means that, well, for users, doesn't change much when you write high-level Spark code, but when you write low-level Spark code, like the one needed by an engine, you eat those incompatibilities, and that's why Comet, the version of Comet that we tried with EMR wasn't working out of the box. Cloudera is a bit more cleaner in that. Sorry?
Databricks, is it possible?
Databricks doesn't allow you to do that. Databricks tries its best to push its Spark runtime, but Databricks has Photon. Photon is a direct competitor of Apache Comet or other accelerators, because it's definitely the same. It's logically not exactly the same, but is a C++ engine plugged into Spark. So technologically, it's very similar. Another interesting project which probably is a bit far-fetched, and it's not taking let's say, the popularity of Comet, even if it's older, is Gluten, Apache Gluten, again, started by Intel. The goal is to provide a layer to plug different engines into Spark. And then there are different engines that are compatible with Gluten. One is the ClickHouse engine, which is built in C++. Another one is the Voltron, the Velox engine built by Facebook. So there is a lot of different projects in this space. We've used some of them and see some good results. The real problem is that you need to still know a lot of low-level details to make them work. You can hit some walls because they are they're not very mature. But
not plug and play.
Well, they promise that, but in the end, when you dig a bit, it's not that plug and play.
Clear. I was thinking another bottleneck of analytics is network transfer, because very often analytics query are reducing the result set to a few lines, but in some other case, when you need to plot maybe a huge map with a lot of points of interest or other kind of visualization, you need to transfer. So the result of the query is still transferring a lot of rows. So typically JDBC, ODBC are becoming a bottleneck even in distributed computing, because everything then is streamed on a single endpoint. We have seen a lot in the past. Arrowflight, we did a lot of experiment with this protocol. What is the adoption curve of this? Do you see in the market? Do you see it useful, or there are other problems on top of it? Maybe Ugo. I think you had a lot of experience on this.
Oh, actually, in terms of the ability to adopt such a technology, such ecosystem, there should be an entire set of tools that can actually feed the whole data value chain. I'm very focused on the end-to-end process in general, so I like to see how the story actually ends up. I will say that at the moment there is a locality in the adoption of this kind of technology. There is a market that is targeting lakehouse engine, like Brainio and data fusion and Rust-based implementation of Arrow, as Antonio was mentioning. I wouldn't say that there is at the moment an overall maturity of these ecosystems, even if there is a lot of rumor and noise around it. And probably we will see. It's very interesting what Antonio was saying, also Francesco was saying about the layer of abstraction, because this is what put in who works on data can be data engineer, machine learning engineer, to abstract from technologies. Probably there is not the right maturity to bind the experience for a data developer and the technology behind. Probably we will see some maturity in the future, since the need for it is quite clear. It's quite clear because there's a plethora of in the field of accelerated analytics, that is our topic today. We see a plethora of engine, massive parallel processing engine like Flink, Spark, that actually needs to have that abstraction, but under the hood, leveraging those technology. I don't know, we've seen, for instance, many times shuffle management for Spark. It's something that actually requires deep understanding of the technology to optimize also use cases. There is a bind between the knowledge and the abstraction, the knowledge of the technology and the abstraction for real optimization. And at the moment, there is not that clarity. So for traditional MPP engine like Spark and now Flink, I would say there is this kind of awareness. Probably there is not for Arrowflight as well, and this ecosystem. And I may foresee that this is going to grow in the future as soon as the demand for fast analytics will grow.
Just for me, if clients, so I mean the drivers on the driver side, so BI tool and so on would support arrow flight and receiving the data from the query layer in parallel with the possibility to process also this data in a multi-thread environment without having a single entry point. I think would unlock incredible performances on their side. So I really don't understand why they are not supporting this protocol that, for those that don't know, basically is allowing to stream the result set of a query on multiple streams and in parallel towards multiple endpoints. So it would increase the bandwidth of the data transfer, but also on the other side, who is receiving the data can process them in parallel natively. So to me, it would be a great improvement in the ecosystem. But as you said, if it's not end to end, the benefit will
Yeah, but also it's difficult for. I mean, I believe that a large enterprise that is going to, to get ready with new technologies must care about maturity, and this is fine. I mean, Antonio was actually mentioning Databricks Photon Engine. In that case, there is a good maturity of the product overall. So the photo engine is basically transparent to final users. You're moving your knowledge from Spark to Spark. Actually any specific clue about the technology behind. And so this is a kind of shift and lift, mental shift and lift from one technology without actually caring about details. When you want to take advantage of the full, value chain from ingestion to analytics, then you start also looking into the current landscape. You have like a Sapana in-memory engine that is one of the most popular, cube-based technology for to let doing new analytics fast, even if the freshness of data is not really a guarantee, since you don't know. I mean, you don't know the ingestion process layer, how they are going, and so there is a I would say a good integration problem now to solve between the old technology and the new ones, and also a maturity difference between them. So until we don't face the right way to troubleshoot and integrate those technology end to end, the value of those probabilities is not going to be very clear.
And because you mentioned integration and developer experience, one of the most clever way of using in-process analytics is basically embedding DuckDB in CI/CD to run integration test, for example. So, Francesco, how do you see this new trend changing the data engineer workflow? How the data engineer will be impacted by these kind of tools?
Yes, Paolo. I think that data engineers typically spend much of their time working with SQL-oriented data pipeline, and yes, also working with such form of data framework API and stuff like this in order to build your their ETL processes. Okay, so as long as there is interoperability with existing languages and technology, the effort required from their side will be minimal. Okay, if there is a layer of abstraction, such as Data Frames API, Pandas API, or SQL compatible interfaces, the core skill set of a data engineer isn't likely to change insignificantly. However, the situation, I think, is entirely different if ETL developers are asked to write code using, for example, in hardware acceleration write code directly in CUDA to leverage that kind of capabilities. While using, for example, Polars, this is something easier because their API is similar to Pandas, so this is not going to bring difference in their way of working. Also, embedding a DuckDB database for their unit tests is going to accelerate also their internal productivity. So in the market, also in the past, there are a lot of, let's say, traction about making this layer of abstraction usable in order to stimulate the adoption from the developer side. Okay, this is what I think is going to be usable. Is going to happen in the market and in the future. Okay, this is the major impact of accelerated analytics on the data engineers' day-by-day work. While another things that should be kept in consideration, that things are going a little bit, also the landscape become a little bit more complex for data architects or CTO that should understand and better understand the advantage brought by these new databases that use accelerated features. So because they have to drive the data strategy initiatives within their company, and they have to be aware which are the benefits and also which are the cons of the adoption of this kind of strategy.
Antonio, what is?
Yeah, I want to add one thing that is probably what is going to change with these new trends, that they are all with their strengths and also with their problems, is that maybe we need to step even higher from the interface that we are using. So, for example, coming from a software developer background, I hate the fact that most data engineering tools are not built to be easily testable. I worked in a project on Snowflake lately, and hated the fact that Snowflake doesn't provide you a way to do unit tests. You need to connect to Snowflake and run queries and see what happens and build your practice around that. I think that that's why we need to do a step up, because, well, sometimes you're going to use a proprietary software like Snowflake, but Databricks now, it's kind of the same for some smaller parts. And so what you want to do is step up a bit, use an API that then can be converted to different engine. One really good thing in this space is SQLglot. SQLglot is a library, open source library, that actually translate SQL dialects between different SQL dialects. That's very useful because you can build your queries and test your queries locally using DuckDB or some other local SQL engine, and then run them in production with Snowflake or BigQuery or Databricks. And there are other two projects that are going one step further. One is IBIS, again, open source, built on SQLglot for in some parts. IBIS offers a data frame API that can be bound at runtime with different engines. And the nice thing is also able to go from, so you write your code in a data frame API style, and they are able to convert it to a SQL query. And then you can use it with the SQLglot to run on any engine. So moving a step higher will allow you get all the improvements that the underlying engines will have. The problem with moving a step higher is that you are losing some features in the end, because you end up with a common denominator of features, and that's a problem. We've had problems with the spatial data in that matter. Like if you use generic SQL, you don't have support from spatial data that you have natively from Snowflake, for example, and your game breaks the moment you want to use them.
Clear. This is super cool. So it seems there is a vibrant ecosystem in this field. Plenty of opportunities for cost saving, improving operations, and also accelerate the time to market. So it was very, very insightful for me. Thank you for your contribute to this episode. And stay tuned for the next episode of Data Architecture Elevator. We will discuss about data privacy. And remember to subscribe the podcast. That's very important for us. Thank you so much.